Okay, good afternoon, or good evening, or good day from any part of the world. Um, this is Mr. Philip, and we are going to be starting our class as usual. Today, I want to just quickly go to the unfamiliar part of our topics. I want to go and treat the generally requested topic like the calculus. So let's just quickly launch into that, so that aspect will not be too foreign to people as we are gradually winding down preparation to the exam day. So what is differentiation, or what is calculus? Calculus is actually the family name for all the topics like differentiation, integration, and their application. All right. So the word calculus is not actually something uh, that is mystical in a way. It is not from the word cal, if you know calculation. But when we say calculus, it's about calculating functions that are not actually linear in nature, and you want to try and get some facts from them. Okay. Calculus can take its basic introduction from differentiation. All right. Now, we know that normally the function, let me just write calculus. So like I said, calculus is the family name. It has differentiation and integration. These are like two sides of a coin combined together. Differentiation, and then you have integration. All right. So we are going to be focusing on the differentiation aspect of it, and I'm going to make sure that this lesson is rounded up in the next 25, 27 minutes. So what is differentiation? Differentiation, simply by normal introductory part, is getting the gradient of a non-linear function at a particular point, or simply just getting the gradient of a non-linear function. What do I mean by that? If I have a graph like this, and you can pick any two, you can trace any 2 points on the graph, you can call this one x1 and x2. You can call this y1 and y2. All right, once you have that, you can actually with this form what I call a right angle, where this one is your first point x1, y1, and this is the second point x2, y2. To get the gradient of this line, you are going to say rise over run, that is change in y over change in x. That is what we call the gradient, slope of a line. Change in y over change in s. All right. So that's how to determine the slope of a linear graph. Now, if it is a non-linear graph, can we still be able to find the slope? The answer is yes, we can. And it is the same change in y over change in s. But this time around, the change will be a small change. It will not be a change that happens over a large distance. All right. So let's say we have something like this. You can see that this slope will keep changing as we move along this curve. I would have loved to do something. Let me just erase this. I want this, my axis to be black. So I can use another color to draw the curve. You can see that this is not a straight line. And the gradient you will get, I'm going to use another color. The gradient you will get at this point will be different from the gradient you will get at this point. It will even be different from the gradient you will get at this point. These three different points that I've just painted blue along the red curve line, we have the three different gradients. But you can see that concerning this other one, maybe if I pick my point here and I pick another one here, it will still give me the same gradient that I will have if I use from this point to this point. I will still have the same gradient all along the line because it is a straight line. But when it is not a straight line, the gradient will be different at different points on the curve. And that is what differentiation is all about. So in differentiation, we are saying that is the relative small distance. And I'm going to show you in the next one. Look at it. I want to make it more elaborate now. And then we are going to understand what we have. So let's say this is it. The gradient here, let me use another color. All right, this is better. The gradient here will be different from the gradient here, and it will be different from even the gradient next here. So there are different gradients at different small distance. Now, in the previous slide, I used something like this to represent change. Change in this symbol is a Greek letter, like normal alphabet in English. This is Greek alphabet, and it is called delta. Delta means change. All right. So when we are now talking about differentiation, this is a capital letter delta. There is another one we use like this. It is like a small d. This is a small letter delta. And that is why we say the change we are talking about is not a big change. So for a curve, we are not going to use this. We are going to use this one. Small, very small change. So at this point, if we want to find the gradient, we'll just draw a small triangle around that point to be able to find change in y over change in x. That's what we do. We just draw a small triangle around that point to be able to find. We just trace little paths to the x1, x2, y1, y2. Very small change around it to be able to determine the gradient at that point. So that is what we refer to as, in previous one, we said delta y over delta x. This one is big changes. But when it is small letter y, small change in y over small change in x, that's what we'll modify to the normal English letter dy and dx. And that's why we call it dy dx. Dy dx. So what are the things we need to know about dy dx? I'm going to be giving you there are two methods you can use. We have what we call the first principle. And because JAMB is not a theory question, it is a OBJ, multiple choice. So I'm not going to be giving you the definition or the workings of the first principle. I will just give you the workings of the indicial rule. All right. We are not going to be working with first principle. But if you need more information on solving differentiation with first principle, that would be a different arrangement that we can work with. But it's good if you know how to solve differentiation from the first principle. It's very interesting. Very, very interesting. And I can tell you that there is no differentiation you cannot solve from the first principle. But if you are making use of the indicial rule, there are some differentiation you cannot solve using indices. A lot of it that you cannot solve using indices. You can only solve basic, what do you call, algebraic equation of differentiation using indices. All right. So all said and done, we are going to be talking about dy dx. So this is what you need to know. Basic rule. Hold on there. Okay, I don't need this. So if this is the rule, if y is equal to ax raised to power n, then dy dx will now be equal to n dot ax raised to power n minus 1. This is a very important I don't want to use times. I'm using dot to mean multiplication so that my times symbol will not confuse you with the x. All right, because x is a variable. X is a variable. So please note that. I'm going to put that in a box that anybody should be able to know. It's a basic rule, initial rule for solving differentiation. If you have an equation that says y is equal to ax raised to power n, then our dy dx will be n dot ax raised to power n minus 1. And that's once you are able to understand this, you don't have problem with differentiation. The only thing is that you need to now learn some rules of how to go about your differentiation. There's a lot of rules that you need to learn about differentiation. Okay? Yeah, there's a lot of rules you need to learn about differentiation. So, for example, let me see. If you have y to be equal to 3x squared, if you have something like this, in this case now, you compare what you have here with what you have here, and then you see your y is standing alone. Your a is 3, your x remains, and your n is 2. So you just put that into that. If they say find the differentiation, it means dy dx will be equal to, the n is the power, so 2 multiplied by 3. I don't want to use multiplication so that you won't confuse multiply with you won't confuse multiplication with x. Then 2 raised to 2 minus 1. That is the rule. I'm just following the rule. So our answer will be 6x raised to power 1. Anything raised to power 1 is that number. So we can just decide to ignore the 1. Anything raised to power 1 is that number. So 6x. What if I have y is equal to x raised to power 3? This is number 1. This is number 2. If I have y is equal to x raised to power 3, here now, my y is standing alone, but my a is like nothing is existing. But don't forget that here 3 is the power of x. So there is an invincible 1. A 1 is multiplying it. If there's no number, it means that number existing is 1, because anything times 1 is that number. So my a is 1. So what I will now have is dy dx will now be equal to 3.1x raised to power 3 minus 1. And that will be equal to 3x squared. When you are solving from the first principle, it doesn't look this simple. It doesn't look this simple when you are solving from the first principle. But I can tell you that this is where you enjoy solving with indices, because you get your answer quickly and you'll be happy you did. All right. But we can get something more complicated than this. And let me give you another one. Okay, hold on, please. Okay, so from here, let's quickly check another question. Let me pick you this. Now, this time around, I want to go a bit further. Question 3, 3x raised to power 4. And I need you to pay attention to this. Minus 5x square plus 16x. Okay, something like this. We want to differentiate this. Of course, in a way, our y will be there. Let me just write the number here so that my y can have. And in most cases, they may not put y. All right, maybe I should just let you know that it's not in all cases you see y there. All right. They will just tell you differentiate this function. That's what they will say. So it doesn't matter if there is y or no y. Okay. So the instruction is we want to differentiate this function. And if you are differentiating this function, you just say the differentiation or dy dx. That is the change in y with respect to. So in other words, I'm saying that it is an equation, definitely. An equation with the power of x more than 1 will always give a curve. You know, I didn't say parabola or hyperbola, it is a curve. So the curve can be in multiple folds, it can be in single fold, upside down, or downward up, anyone, but it's a curve. So that's what you should have at the back of your mind. So in this case now, I want to do some compression. I'll multiply my 4 by 3, that's 12. My x stays. I'll subtract 1 from 4, and that gives me 3. This sign remains. I'll multiply 2 by 5, that's 10. I'm dealing with each of those functions term. I'm dealing with each of those functions term by term. So it is when we learn to deal with each of those functions term by term that we'll be able to get all of these things done. Okay, so we have that. Then x, of course, here now, don't forget that this is 5x squared. So 2 has multiplied 5 to give me 10. 2 minus 1 will give me 1. So x raised to power 1 remains x. I won't touch that. But the last one, 16. Now, there x is just x raised to power 1. So if I use that one to multiply 16, I'll get 16. But 1 minus 1 is 0. So I think I will need to do this separately. So let's say I'm doing 16x. So it's the same thing as saying 16x, because you need to understand, I'm going to delete it back. 16x raised to power 1, because anything raised to power 1 is that number. Now, to differentiate it, I'll say 1 times 16. Then x raised to power 1 minus 1. That's where I'm able to get my value. So 1 times 16 will give me 16, and then I'll have x raised to power 0. Anything raised to power 0 is 1. So 16x means 16. 16 times x raised to power 0 simply means 16 times 1. So the answer will be 16. That's why this 16 is there. All right? Okay. That case, it means is that the means will disappear. If the power of x is 1, it means that x will disappear. And I want to show you another one. This explanation, we just use it so that you will understand how we got to the concept of how we got our answer there. Most of these questions come, and when you see them in question, you think they are difficult. They are not. They are not. Sometimes they present those questions in what format, in a way, using the equation of motion and all of that. I think I've dealt with this effectively when I was teaching physics students, but that's not. Let's just continue. Okay, so let's see this next. For 4, if I'm just giving random questions. Y is equal to 7x squared plus 5x plus 4. All right, 7x squared plus 5x plus 4. And please, when you are dealing with this, I told you it is term by term. So understand the notion of the sign that each of the term carries. Understand the notion of the sign that each of the term carries. I'm going to be giving you some sophisticated, not hard, but they are sophisticatedly simple. All right. And you can easily just make mistake and get them wrong. All right. But then dy dx here, dy dx here, of course, 2 will multiply 7, so I'll get 14. X, 2 minus 1 is 1. So x raised to power 1 just x plus, sorry, okay, good. 1, x raised to power 1, 5x, x raised to power 1. So that will just be 5. 1 minus 1 is 0. So anything raised to power 0 is 1, just like I did for 16x. So it's just the number that will retain. Then plus what? 4 has no x. Most times you've been taught that once it is 4, you can just throw it away. But is it that you can actually throw it away? No. Look at what happened there. 4 simply means 4 times x raised to power 0, because anything raised to power 0 is 1. So 1 times 4 will still give you 4. But this 0 now, as a power of x, will now come and multiply 4. 0 times 4, x raised to power 0 minus 1 will give you minus 1. So it doesn't matter anything you have here. As long as 0 is multiplying everything, so everything becomes 0. So you need to understand all this method. So it is not that you are just throwing it away. It is by the happenstance of the fact that there is no x factor, or which means x is carrying a power of 0. And by the time you carry that power of 0 to multiply everything, anything times 0 gives you 0. So that's why the 4 will disappear, and this will be the only answer you have. Yeah, that will be the only answer you have. I hope in the next 2 or 3 weeks, we'll be able to deal with the basic concept of differentiation, and everybody will be happy we did. Okay, so I want to take away this. Now, like I said I'm going to give you some question. Let's see this. What if you have y to be equal to 5 over x square? What if you have something like this? Of course, which sometimes happen, can have 5 over x square. When you have something like this, you are going to write it in a linear format. Linear format, you still remember law of indices. So I can write it as y to be equal to 5 times 1 over x square, which is the same thing as 5x raised to power minus 2. I can have something like this. Then it makes it look linear. So my dy dx, this is what you need to first do. You first need to rearrange it in a way that it will make sense to you. All right. When you are able to get this done, I'm just giving you the basic rule that you need to know. We are going to talk about, in a way, I've already started talking about addition and subtraction. Maybe next class we'll talk about multiplication. Maybe next time we'll talk about chain rule. Maybe next time we'll talk about what do you call it now? Quotient rule. Of course, there are some rules that you need to follow even when you are using this to be able to get some things done, because that equation can be a bit complicated in some situation. It can be a bit complicated. And I'm still going to give you another variant of this question I'm giving you now. Okay, so in this case, minus 2 will now multiply my 5. I will have minus 10. And then minus 2 minus 1. This is where you need to be careful. You know, you are supposed to subtract 1 from the power. So minus 2 minus 1 becomes minus 3. So my x now becomes raised to power minus 3. You can now rewrite it in another format. This is the question here. Let me box the question for you. This is the question. It depends. And then this is my answer. Maybe I should leave you to figure out how can you write this answer in a fractional form. I've written it in a linear form. Of course, you just follow the way I arranged it so that you won't get too confused. This one is multiplication, not x. I'm just trying to avoid misconception. Yeah, 5 dots. So let me use this as dots so that you don't misconcept multiplication for x. So let my x appear as x, and every multiplication will be denoted by dots or a very thick dot or anyhow. So this is it. Okay, what if we have another one? So this is the question, like I said. Let me show you question, then answer. answer. All right, that's the answer there. I just want to write the answer to show answer. Question answer. Okay, so let's check this other question. I think I would like this. Question 6. If you have y is equal to minus 5 over x, let me just still use x squared. Let me use the previous number. If you have something like this, it can come with some other terms of equation, it doesn't matter. Maybe I should just do that. I'll try and get it solved in no time, definitely. So you have 3x raised to power 4 minus 5 over x squared. I think this is nice. Let me just leave it like this. Your dy dx won't be difficult to solve. 3x raised to power 4 is easy. You just get 12x raised to power 3. 4 times 3 is 12. 4 minus 1 is 3. So you don't have problem like that. Then, now, look at this one now. Minus 5 raised to x raised to power minus 2. You know where that is coming from, previous question. So it won't be difficult for you to relate. But this time around, you have not differentiated this. So it's only this one you have differentiated though. So we want to work on this now. And that should be equal to 12x3. Now, minus 2 times minus 5 will now give you plus 10. That's where I'm going. Plus 10 x raised to power minus 3. That's what you are going to have, because minus 2 minus 1 will now give you minus 3, which I can now write effectively as 12x raised to power 3 plus 10 over x raised to power 3. So this is the answer. This is also an answer. Anyhow, the reason why I'm giving you all these variants is that JAMB can be funny. You may be looking for the first answer and you will not see anything raised to power 3. What you will see is the second answer. The two of them are the same. This answer and this answer are the same, because x raised to power minus 3 is the same thing as 1 over x raised to power 3, which you are multiplying by 10. So I need you to understand this concept very well. It's all about your negative, sign complications. There's nothing difficult in mathematics. So it's all the plus and minus that most times makes life very difficult to live with. But if you practice very well, if you practice practice different question, you will enjoy yourself and be conscious. Anytime you are in exam mode, don't think too hard. Always feel relaxed, because some people, when they are under tension, they can misbehave. When you are under tension in exam, time is going. You'll be shaking to press calculator. Most times you can press double minus. A lot of things go wrong. So I advise people not to get used to pressing calculator, because any little mistake you make in pressing calculator may affect the entire answer you are getting. So most times work it through, cut the numbers, just make sure your brain is following through what you are doing. It helps. When you depend too much on calculator, it can be very dangerous. All right. So I want you to work on this set of questions. I'm just giving this from my own very this thing. Work on this one. You just differentiate this. I may not remember to go back to it, but at your own leisure, I think you can just take your time to go back to it. 3x minus 4 over x. Think of what you can do with that. Differentiate that. Y is equal to x cubed. I think I've given something in this nation. Let me use x squared. X squared minus 2x minus 5. Try and see what you can do with this. Possibly because I'm trying to target the timing. So let me stop here. At least basic ones that you can relate with. Basic ones that you can relate with. It helps. Let me see how much you can quickly demystify these ones as your assignment, so that you'll be able to catch up. Once you can get this done, then we're on a good start. So that's our assignment. Let me make this one a bit closer to its top. I want to believe I'm not going to be cut out. This is X. Yeah, I want to just separate it. All right, that's nice. Okay, so I can just do it like this. Two different questions to work on. All right, that makes sense. Thank you very much. Who just joined us? I think I saw somebody join. Okay, Suliat, you are welcome. I want to believe you are familiar with the topic, calculus. We are starting from the very simple introductory part, which is talking about the gradient of curve along, some points. And of course, maybe I should just quickly in 1 minute tell you this. They can ask you to differentiate this at x is equal to something. After your differentiation, whatever value of x they give you, just plug it in, you get a real value. Yeah, which is, you get a real number value. So I think I should just stop there. I don't want the meeting to end me or to cut words out of everyone.
You are muted, sir.
Yes, I'm done. I'm just trying to show the slides.
Oh, okay. So I will start physics class right away, so you can join.
Noted, sir.